residual duration less than 10. Okay, therefore, as I said, on the one hand, you are tempted to take a very high design flow because, of course, you see, if I shift Q star in the upper direction, I increase the volume that I get from the river, the volume of water that I get from the river. On the other hand, if I shift Q star in the upper direction, I increase the length of time when the plant is not fully working. You see, D star, if I increase Q star, D star decreases. And therefore, I decrease the duration when the plant is working at full regime, and I increase the duration because D star decreases. For increasing Q star, D star decreases, and therefore I increase the duration when the plant is only partially working. Keep in mind that in general plants, when they work at full regime, they work at the max of their efficiency. When they work at reduced regime, the efficiency is decreased. So if it is an hydropower plant, the efficiency, meaning the effectiveness of the plant to convert energy of water to electrical energy, the efficiency is higher, so there is a better conversion, I take more energy, if the plants work at full regime. If the plant works at a reduced partial regime, the efficiency is lower. So what happens is that, and also keep into account that if you increase the design flow, typically you increase the cost of the plant. The construction cost and the maintenance cost, because you need to build bigger pipes and also turbines. If you use turbines, they are bigger, so you have more costs. So on the one hand, if you increase the design flow, you increase the benefit in general. Even if the efficiency of the plant is on average reduced, in general you increase your income, but there is also an increase of the costs. So basically, if you draw a graph where you display depending on the river flow, on the design flow, so depending on Q star, you display the benefit that you, let's call it net benefit, which means not gross benefit but net benefit. Of course, you get zero benefit if you start from zero Q star, and then typically you have a curve that does like this, with the maximum of the benefit. And then you have a reduction because the efficiency of the plant decreases. And it decreases when the plant works at partial regime. But then there are the construction costs that are higher. Basically, they start, okay, let me display the cost here, net benefit and also cost. The construction cost increases for increasing Q star. So if you make the difference between the two, you see that there is an optimum of the difference. The difference is benefit minus cost. There is an optimum of the benefit which corresponds to a given value Q double star. Let me call it not net benefit because it is misleading, benefit, okay, which means gross benefit, because basically when I subtract the costs, I get what we can call as net benefit, because it's gross benefit minus costs. And let's group the costs under the same curve, which is this one. So this is benefit and this is cost. What is this? It's a cost-benefit analysis. So depending on the use of water, we have to estimate what is the benefit. For hydropower, it's quite easy because we know the price of hydropower, and therefore we can really make a computation by referring to the pocket of the customer, the amount of money that he gets by selling the energy, minus the costs. And also the costs are easy to estimate because construction costs, you have the means to estimate them. As an engineer, you know what is the cost of a machinery, what is the cost of a building, and also the maintenance, you have the means for estimating them. And therefore you need a cost-benefit analysis. Keep into account that for other uses of water, it's more complicated to estimate the benefit. Because, for instance, think about if you take water for irrigating a public park. If you use part of the water that you withdraw for recreational purposes, what is the benefit? You know, it's more difficult to estimate. If it is related to tourism, then it's a bit easier. But if it's related to recreation of local people, you know, this is indeed a value. It's an important value, but to estimate it, it's not easy. There are guidances for estimating it, but it's not easy. For hydropower, it's quite easy. And also, if you use water for civil use, it's quite easy because you know the price of water, etc. And you need a cost-benefit analysis. Anyway, this is the moral of the story. Of course, it is much complicated. And therefore, as engineers, we are not really happy with this solution. Why we are not particularly happy? Because, as you know, we have different steps in the design process. When we have to design a structure, we have different steps. There is the final step where we have to design in all the details the structure, and therefore our evaluation at this step, at the final step, must be very rigorous. And therefore a cost-benefit analysis is affordable, because of course we are already dealing with something that we know it will be realized. It will be done. And therefore, of course, we need to be rigorous, and we have also the economic support to be rigorous. A cost-benefit analysis costs a lot of money, and therefore we have the economic support because we are already sure that the structure will be built. But you know that in the preliminary phases of the design, we are not yet sure that the structure will be built, because there is a first phase where we have to prepare a preliminary design in order to get permissions from the authorities to build something. Also for houses, it's the same thing. You make a preliminary design and then you present, you apply for getting a permission. And if you are granted the permission, then you move forward with the subsequent step of the design. But at the preliminary phase, you are not yet sure that you will have the opportunity to build it. And in particular, when we talk about water infrastructures, uncertainty is very relevant. It's very relevant because it's very likely that you don't get the permission to move forward. When we talk about designing hydropower plants, designing you know, something that is related to taking water from a river, it's an important action. It has an impact. It has a significant impact. So it may happen that you are not granted the permission, and therefore you don't still have the economic resources granted for sure that allow you to make a refined evaluation. So we need simple methods. We need expeditive, quick methods for estimating the design flow, and the cost-benefit analysis is too demanding. So we have to find some empirical ways to simplify this step. We will talk about this in the next lecture. Again, tomorrow please bring the PC, and then tomorrow we don't move forward with the theory. We just spend a couple of hours working and learning if we have time, how to estimate a flow duration curve in practice.